Algebra 2, Chapter 7, Section 3, Solving Power Equations. At the scene of an accident involving an Alfa Romeo, skid marks show that the braking distance is 270 feet. So we have this car. I can't draw a fancy sports car, so I'm drawing a dumb sedan. So an Alfa Romeo does not look just like this, but for the sake of arguments, so it's traveling this way, and we see the skid marks for 270 feet before it stops. How fast was the car going when the brakes were applied? To solve this, we use the following equation. The braking distance is 0.036 v squared, which means the braking distance is proportional to the square of the speed. Okay, so the braking distance we know is 270 feet. In this problem, we need to solve for v. So how can we solve for v squared? First, let's go ahead and divide by the constant of proportionality to get that sort of out of the way of the problem here. So dividing both sides by 0.036, we see that v squared must be 270 over 0.036, which is 7,500. That tells us the square of the speed. So to find the speed, we need to take the square root of both sides of the equation. And we solve taking the square root. The speed must be 86.603 miles per hour. Now, when we're taking the square root of both sides of the equation, we need to be careful. This is not an equivalent operation necessarily by itself. This is because if we imagine an equation where we have take the square root, we have the square here. So if v were negative 86.603, we would get a true statement. So we need to consider the plus or the minus of the square root. And we'll talk about that next. So to solve a power equation that involves integer exponents, we need to take the root of both sides of the equation. And for odd powers, this doesn't pose a problem. But it does not yield an equivalent equation if there's an even power. And this is because there are two possibilities. Think about it. So what if we have this equation, a squared is b? Okay, just an arbitrary equation with abstract numbers. If we were to take the square root of both sides, there are actually two equations we need to write in order to make an equivalent statement to this one equation. We need to write that a is the square root of b or a is the negative square root of b, and this is because the negative square root of b is a solution to this equation. Okay, and we combine the two possibilities with the plus or minus symbol. So we write a is plus or minus the square root of b. And this indicates both possibilities, the plus and the negative. So let's solve another equation. An astronaut's weight in pounds is inversely proportional to the square of the distance, r, in thousands of miles from the Earth's center, and is given by the equation W is 2880 over r squared. Find the distance from the Earth's center at the point when the astronaut weighs 100 pounds. So the weight is 100. So weight is 100. 2880 over r squared. So rearranging this equation, multiplying both sides by r squared, we get 100 r squared is 2880. Dividing both sides by 100, we get that r squared is 2.88. Sorry, that would be if we divided by 1,000. 28.8. And now taking the square root of both sides, we would get that r is plus or minus the square root of 28.8. Square root of 28.8 is about 5.367. 5.367, and the units of r were thousands of miles. It's a little bit strange way of writing it. Plus, do we really care about the negative here? We're thinking of r as a distance from the Earth's center. Distance is never negative for the most part. Usually when we talk about distance, we're talking about a positive number. So we can write the answer as 5,367 miles. Since this was 5.367 and thousands of miles, we can go ahead and write it in thousands, which is a little simpler for our answer. Let's solve some power equations to practice this plus or minus idea. A, we have x squared is 64. Taking the square root of both sides, we get x is plus or minus the square root of 64. The square root of 64 is 8, because 8 times 8 is 64. So this will be plus or minus 8. X cubed is 64. So this first, the A has two answers, plus or minus 8. If I don't see the minus 8, you're not getting the entire credit. There's two solutions to this equation. X cubed is 64. Now if we take the cube root of both sides, we get x is the cube root of 64. Notice we don't write plus or minus. For the odd powers, the sign is preserved. The cube root of 64 is 4, because 4 cubed is 64. 4 times 4 is 16, times 4 is 64. X to the fourth is 64. We get x is plus or minus the fourth root of 64, which would be the square root of 8, which is 2 square root of 2. So we can write that as 2 square root of 2. But we must not forget our plus or minus. So for D, we have x to the negative 2 is 64. Remember, this is the same as writing 1 over x squared is 64. And swapping the x squared and the 64, we can multiply both sides of the equation by x squared, and then divide both sides by 64. We get that 1 over 64 is x squared. So therefore, taking the square root of both sides, I have x is the square root plus or minus the square root of 1 over 64, which is, remember, the square root of 1 is just 1, so this will be 1 over the square root of 64, which is 8. So plus or minus 1/8. X to the minus third is 64. Solve this equation. Again, this is the same as writing x cubed is 1 over 64. So taking the cube root of both sides, I get x is the cube root of 1 over 64, which is 1/4. Only one answer because it's an odd power. X to the minus fourth is 64. We get x to the fourth is 1 over 64. So x is plus or minus the fourth root of 1 over 64, which was 2 times the square root of 2, which we don't want to keep the square root of 2 in the denominator. We would need to rationalize that. Multiplying by square root of 2 over 2, we get plus or minus, or multiplying by square root of 2 over the square root of 2, plus or minus the square root of 2 over 4, because we have square root of 2 times square root of 2 is 2, 2 times 2 is 4. So to kind of think of that again, power equations can have two solutions when the power is even. They could also have no solutions when the power is even, because we might have a situation where we have x squared is negative 4. Well, the square is never negative. So there's no solutions to this equation. We could also have one solution, x squared is 0. The solution is just 0. Or when we have an odd power, there's only one solution. Now, also, we haven't seen this yet, but solving power equations, we may use non-equivalent steps which yield extraneous solutions. An extraneous solution happens when using a non-equivalent operation like squaring both sides. So to solve this equation, we were square rooting both sides. But for solving certain equations, like a radical equation, square root of x is 4, we would need to square both sides, and that is a non-equivalent operation that can lead to an extraneous solution. An extraneous solution is not a solution to the original equation, and you should give it as an answer. So let's do some examples. First, let's talk about how many solutions. So how many solutions are there to each equation? So we need to rearrange this to think about it a little bit. X cubed is minus 773 over 22. We have an odd power, so we'll have one solution, always. One solution. And maybe we can, since it says how many solutions are there, we can just write 1. B, what if we have, so we have x squared is minus 773 over 22. Well, the square isn't going to be a negative number, so we have 0 solutions. C, rearranging, we have x squared is 773 over 22. Well, we'll have 2 solutions, plus or minus the square root. And D, we have 0 is 22x squared. So x squared is 0 by dividing by 22. There's only one answer to this, 0. So one solution. So just to go over the cases again, an odd power, one solution. Even power, we could have none, where it's negative. 1 if it's 0, and 2 if it's positive, for the plus or minus the square root. Right, so the solution here is plus or minus the square root of 773 over 22. Now let's solve some power equations with fractional powers. The square root of t plus 9 is 21. So subtracting 9, I have 21 minus 9 is 12. And then squaring both sides, I have t is 144. But as I pointed out in the previous slide, squaring both sides might cause us to get an extra solution, an extraneous solution. That's not an actual solution. Let's go back and plug in. Square root of 144 plus 9, does that equal 21? So the square root of 144 is 12. 12 plus 9 does equal 21. B. So this is the answer. Square root of t, subtracting 21 from both sides, we get minus 12. Now if we square both sides, we'll have t is 144. Same answer as before. But let's check. If we plug in 144 to this equation, does that plus 21 equal 9? Square root of 144 is 12. 12 plus 21 does not equal 9. Something's wrong. This is not a solution. It's extraneous. What went wrong? Well, if we think of this equation, we're asking, when is the square root negative? And the answer is, we don't have a real numbered value that does that. So there is no answer, no solution. No real numbered solution. C, we have this 1/5 power. How do we deal with that? First, divide by 2 to get rid of the coefficient here of a to the 1/5. Now, take the to the fifth power of both sides of the equation, and we get a to the 1/5 to the fifth. That gives us a to the first power, which is just a, 5 to the fifth, which is a pretty big number. 5 times 5 times 5 times 5 times 5. No problems here with extraneous solutions or multiple solutions because it's an odd power. So, in summary, if we take an even root of both sides of an equation, we must be sure to write both solutions with a plus or minus. The only exception is we don't write plus or minus 0 because we don't have a negative 0. Just write 0 if that's the answer, which will give you one solution. If we have an even root, there may be no solutions if one side's negative, or one solution in the case of 0, which I just mentioned. If we raise both sides of an equation to an even power, we may get an extraneous solution, like we saw with the square root of t is negative 12. So always check a potential solution in such a case against the original equation. For odd exponents, there's no problem, as they preserve the sign of the number.